Okay, so next in our series of topics, once again motivating the question of why would you care about databases and active record, which I'll describe next. So here's the question that this is trying to solve. So far, when we talked about object orientation and how classes are organized, we talked about classes, there's instances, and instances can have attributes. So this is a record-oriented way of looking at the world, right? We have instances of things like bank accounts, and each instance has some attributes associated with it. So in our web apps, we're going to have to be able to store that kind of data somewhere. We're going to have to be able to retrieve it and search it. And that means that we have to have some relationship between the way we store the data and the way that we manipulate it in our programming language. So the different ways that people have tried to solve that problem, create that mapping, lead to different ways of thinking about how you should organize and store your data. So going back to our diagram, where are we today? We are still kind of diving down into the structure of the application tier, and we're going to look at how the model part of Model View Controller is handled in the Rails framework. And again, I'm going to present more than one way to do it besides the way that Rails does it, to send the message that just because Rails does it this way doesn't mean that this is the appropriate way for all applications. So let's talk about objects in memory versus objects that you store. You know, we've seen when you create new classes and you create new instances of those classes in Ruby, obviously there's some in-memory representation of those objects and their attributes. So the question here is, how do you represent that object in storage in such a way that later on you can essentially take that object back out and reconstitute it, right? It's as if you need to store the object, kill the program that was manipulating the object, and know that later on you can restart the program, read the object back, and not lose any information. So generally speaking, the process of doing that is called marshaling. It's also called serialization. There's a subtle nuance and distinction of meaning, but not one that we're going to worry about. The idea is that if I marshal an object, it means I'm converting it to a new format that makes it amenable to doing something. Usually something is storing it or transmitting it someplace else. And I'm doing it in such a way that later I can unmarshal or deserialize and get back a representation in my language that is in every functional way or every behavioral way equivalent to the thing that I started with. So in our case, we're talking, for example, about a movie with attributes like name and rating. How might we take the in-memory representation of that and store it someplace? And in particular, the operations we need to do whenever we're talking about managing stored data, we can create a new copy of something, in our case in the persistence tier. We can read an existing copy of something we stored before. We can update. So for example, we could change the name of a movie and want to keep that change permanent. And of course, we can delete things from permanent storage. So collectively, these are the CRUD operations. And the way that Rails organizes its models is according to another design pattern called active record, whose main conceit is that every model, every type of thing, like a movie, knows how to CRUD itself using a set of common mechanisms that all the different models share. Now, if you come from, for example, the PHP world, you're accustomed to there being an object that represents the connection to the database. And you create queries and things like that, which you hand off to that object. The active record view of the world is quite different. The database isn't really visible to the programmer as an explicit abstraction. The abstraction is, here's a collection of operations you can do on this kind of object. And it happens to be the case that the object is going to be stored in a database. We'll talk more about that separately. But the active record view of the world is there's a common set of machinery that allows any type of active record object to do these basic operations. Now, in the case of Rails, I think many years ago we all agreed that relational databases have won the battle for being the way that most web apps store their data. And roughly speaking, in a relational database, each kind of model that we have is going to get its own table in that database. All the rows in the table have the same structure. That's part and parcel of what relational databases means. And one row in the table is one instance of a particular model, of a class, particular model class. So since each row is one instance of a model, it stands to reason that the columns would be the attributes, and each column stores the attribute value. Each row also has a unique primary key. By convention, in Rails, this is an integer, and it's called ID. Don't let that confuse you. ID is not really a property of movie, the object in Ruby, right? But it is going to have to be a property of movie, the object that's stored in the database. So this is one example of how abstractions aren't really perfect, right? We're saying that we want to make a mapping between objects in memory, objects in the database, but in fact, they're not really going to be identical. There's going to be a few ways in which they differ. And as we'll see, the reason for those differences is because the way a database wants to manipulate an object and the things that you have to represent to allow the database to do so have some overlap, but not complete overlap, with how Ruby wants to manipulate an object and what kinds of things you might want to do with an object in the Ruby world. So collectively, if you look at all of the tables in a particular database, what columns they have and so forth, what the types of those columns are. That is collectively called the schema for that application. Now, what's an alternative? Suppose you didn't want to do active record. What else do people do, and why might they do it? Datamapper is a different way of thinking about data that says every time you define a new kind of model, you also have to come up with a mapper for that model. The mapper is responsible for figuring out the specifics of how that type of model is going to be stored in the database. And a reason you might want to do this is that it keeps the mapping strategy independent of a particular type of data storage. For example, as we'll see, Rails models, because they're based on active record, because they know they're going to be stored in a relational database, the active record machinery takes advantage of a lot of things about relational databases. If you've read about things like the NoSQL movement, people using things like MongoDB and SimpleDB and a lot of other databases, most of those are non-relational. They lack a lot of the features for data manipulation that relational databases have. So in those cases, you can't really use active record because of its heavy reliance on the relational model. You could use something like Datamapper, but in fact, you don't get anything for free. If you use Datamapper, then a lot of the work that in active record is done for you, now you have to redo that work yourself, and you have to reinvent it to fit what your database is able to handle. This will become a lot more clear when we start talking about more advanced concepts like associations between models. But just as a data point, Google App Engine uses the Datamapper pattern. That's the way that they recommend you write apps against their storage system, because one of the nice things about Datamapper is by leaving out some of the complex relational database stuff, it actually allows their storage system to reach much larger scale than most relational databases can reach. So that's an example of an architectural trade-off. When you get to a certain scale and using a relational database for some things just is not in the cards anymore, here's an alternative that you could use.